Everybody, let me show you around Multisim. So once you sign up and log in, under resources up here, there's help, and then there are some tutorials we should definitely go through: creating a design, simulating a design. So I'll show you how that works. So let's see, up here on the right, let's see, create a circuit. So let me just make something simple out of resistors, and then we can simulate it. Okay, so let's start with adding a supply. So here under sources, let's just put a voltage source, a DC. Well, we're not going to do AC in this class, right? So DC, just plop it down somewhere. And then if you click on it, you see how you can like move the slider. You can times 10, so you can make it hundreds of volts, kilovolts, megavolts, or down you can be in the millivolts. So let's just pick something, and then you can kind of click this way to adjust up or down. Okay, now let's add some resistors. So here, passive, so there are resistors, capacitors, inductors. Later in the semester we'll do op amps, and then next semester you'll do transistors. You can also just press on the keyboard R, and then a resistor pops up, and you can just plop it down, and then you can rotate it here, or for example, while it's in the air, you can press Shift R, and then it'll rotate it before you plop it down. So, okay, let's just put a few. A couple more. Okay, well, maybe we don't have to have them squished together so close. Let me spread these out a little bit. Okay, so put down a bunch of resistors, and now let's wire them together. So when you get near one of these edges, this other, what looks like a wire spool icon shows up, and this is how you kind of wire the circuits together. And just try and make it neat looking, so everything is kind of lined up and at 90-degree angles. Okay, and then if I get from here to the middle of another wire, it makes a node, a junction, like that. See that junction here? Okay, and there we go, we got a circuit. But really we want to know, what's the voltage across each resistor? What's the current going through each resistor? And that way you'll know everything, right? You know the voltage and the current, multiply those together and you know the power. So to measure, you see here, you can add probes, but the simulator needs to know where is it considered 0 volts. So it needs a ground. So right here, you should add a ground, and you can put the ground wherever you feel like. Like you can put it here. Right, so let's say like that's the ground. Or, you can put it somewhere else. You can put it here. You could put it down here. Right, just wherever you decide. So let's say I put it there. Okay, so now this entire node is considered 0 volts. So now when I pick up the voltage probe here, so let's say I put the probe right here, we're expecting this to be 20 volts, right? And so up here, you see where it says interactive? This is how you choose the type of simulation. So I would go with this DC operating point. I think that's a good choice. And then here there's this play button. You click play. So that runs the simulation. And this DC op shows the number just right there. Or you can click graph, and then it shows the number, right, 20 volts, or split. It shows the circuit on this side and then the number on this side, and you can like resize these. But I think just have the schematic open, and right, look, the number is just right there anyway. Okay, if we move the probe here, this will tell us the voltage with respect to the ground here, 0. Right, so I click play. Okay, it's 7.69 volts. Oh, actually, I made all the resistors kind of boring, right? They're all kind of the same number. Let me just change these so that it's at least more exciting. Okay, just make them different values. So we have kind of boring circuit. Okay, so I'm going to add a probe back here. I mean, we know this is 20 volts, right? So this is 20 volts with respect to the ground. This is 11.889 with respect to the ground. So that means this 20 minus 11.889 is the voltage across this resistor. Right? And then let's say you want resistor 2. I'm going to pick this probe up, put it here, run the simulation. So now I know, right, it's 11.8 on this side, 6.85 on this side. So I take the difference, and that's the voltage across R2. Right? See how it works? For R3, like this. Run the simulation. See, 6.85 on this side, 3.9 on this side, so I take the difference, that's the voltage across. So now you can get the voltage for all the resistors, right? How about current? So current is here. Current is in series. So like physically when you're wiring a circuit, you would disconnect the wire, put the meter here, and then run one side to one side of the meter and then this to the other side of the meter. But for the simulation, it just goes, you kind of just plop it down right in line. Okay, so if I run this, then right, it says 202, positive 202.7 to the right. Just as an example, it's the same over here. So it says negative 202, but the arrow is going to the right, which means the current is actually going to the left. Okay, so let me put it over here. And then let me put a few more. Okay, so right, what we have here looks like KCL, right? Let me run this. 202 going into this node, 83.89 going out to the right, 118.8 going down. Right, so you take the algebraic sum, it adds up to 0. Right, what goes in the node is the same as what goes out, so that's KCL. Okay, so now you know, right, how to get the current. Like, you want the current here or here, right? So move this over here. So you can get the current going through each resistor. Right, so now you know how it works. Okay, so Let me know if you have any questions. I'll see you on the next video.